Hello students. Today we will discuss acids and bases. These are present in substances that are used in our daily life. Like acids are present in vinegar, lemon juice, battery acid, and soda. Bases are also a part of our daily life and are found in baking soda and ammonia, which is part of hair dyes and soaps, and borax, which is used in cleaning and for laundry purposes. How did all these start? In modern chemistry, we have a sound understanding of acids and bases. Also, few of the bases are called alkali. No doubt, acids and bases pervade our lives from the laboratory to the kitchen, and these crucial substances are used as laboratory reagents, industrial catalysts, food additives, and cleaning products. However, throughout the history of chemistry, it took centuries to understand these substances fully. During the time of the ancient Greeks, the properties of acids and bases were only vaguely understood. As the Greek influence waned and their knowledge passed on to the Romans, they began to refer to sour substances, such as vinegar or lemon juice, as acids. The words acid and acetic are both derived from the Latin word for sour tasting, acea. Bases, by contrast, were not as well studied, although they were recognized as substances that would neutralize acids. The easiest way for the ancients to create bases was to take ashes from a fire, a process well known to the Greeks, who mixed ashes with animal fat to make soap. Bases are also referred to as alkalis, a word derived from the Arabic word for roasting, although later it was called base, but when, that is unclear. Do you know that all alkali are bases, while the opposite is not true? There are a few differences between alkali and a base, which are as follows. Alkali compounds are the types of bases that dissolve in water, whereas the base neutralizes the acid. Alkali is used for bases of metals of group 1 in the periodic table, whereas the base is a compound having OH- ions. Examples of alkali are NaOH, KOH, and examples of bases are NaOH, KOH, AlOH thrice. Even though the acids and bases were widely used, there was still a need of defining them. Lavoisier was the first scientist who defined these two terms for the first time. The French chemist Antoine Lavoisier, 1743 to 1794, was the first to study the essence of acids and bases. He guessed that perhaps the characteristic that makes an acid is the presence of oxygen. He called these oxygenic, from the ancient Greek word for acids, which seemed to connect them to oxygen. However, English chemist Humphrey Davy, 1778 to 1829, showed that this theory could not be true, since many acids do not contain oxygen. Justus von Liebig, 1803 to 1873, a German chemist, was the first to associate acids and bases with hydrogen instead of oxygen. It was after the explanation given about ions by Faraday in 1834, the first ever theory of acid-base, which involves the formation of ions, was described by Arrhenius. Arrhenius defined acid and base in 1887. Acid as the substance which can release H plus in an aqueous medium, and base as a substance that can release OH minus in the aqueous medium. As we now are acquainted with the history of acids and bases, let's move on to a comparison of acids and bases. Acids are the substances that release H plus in an aqueous medium, sour to taste, and turn blue litmus red. On the other hand, bases are substances that release OH- in an aqueous medium, bitter to taste, and turn red litmus blue. While both show reactivity with active metal, forming a salt, and H2 gas is released, base reactivity is a bit limited as it can react with only a few metals. Acids and bases can also react with each other, forming salt and water. It is a type of double displacement reaction in which H plus from acid and OH minus from the base react with each other to form a water molecule, and salt is obtained as the byproduct. For example, a reaction between CaOH twice and H2SO4 will produce different ions, which are HSO4- from H2SO4 by removal of one H plus, and if two H plus are removed, then SO4 2- is formed. While CaOH twice, when releases one OH-, it forms CaOH plus, and on further removal of remaining OH-, we get Ca2 plus. When we combine these ions, we get different products. Like, when CaOH plus with HSO4- forms CaOH-HSO4. At the same time, Ca2 plus with SO4 2- forms CaSO4. Likewise, CaOH plus and SO4 2- forms CaOH twice SO4, and Ca2 plus with HSO4- forms CaHSO4 twice. The chemical reaction related to the same can be stated as CaOH twice plus H2SO4 gives CaOHHSO4 plus 1 mole of water. When 1 mole of each is reacting to form 2 moles of water, salt obtained is CaSO4. When CaOH twice is taken in 2 moles and sulfuric acid in 1 mole to form 2 moles of water, then the salt is CaOH twice SO4. Likewise, when the opposite is done, that is, sulfuric acid is taken in 2 moles and 1 mole of CaOH twice is taken, then CaHSO4 twice and 2 moles of water is formed. Let us summarize. We learned the difference between alkali and base. Alkali compounds are types of bases that dissolve in water, whereas the base neutralizes the acid. Alkali is used for bases of metals of group 1 in the periodic table, whereas the base is a compound having OH- ions. Examples of alkali are NaOH, KOH. And examples of bases are NaOH, KOH, AlOH thrice. Acid is the substance that can release H plus in an aqueous medium, and base as a substance that releases OH- in the aqueous medium. Next is the difference between acids and bases. Acids are the substances that release H plus in an aqueous medium, sour to taste, and turn blue litmus red. On the other hand, bases are the substances that release OH- in an aqueous medium, bitter to taste, and turn red litmus blue. While both show reactivity with active metal, forming a salt, and H2 gas is released, base reactivity is a bit limited as it can react with only a few metals. Acids and bases can also react with each other, forming salts and water. It is a type of double displacement reaction in which H plus from acid and OH- from the base react with each other to form a water molecule, and salt is obtained as the byproduct.